Hi, another teardown of some weird stuff today, courtesy of eBay. This, which looks like some horrendous piece of military kit, but it's actually an image intensified sensor. I believe it's a Vidicon tube, so it's effectively an image intensified video camera made by EG&G, who make all sorts of funky scientific stuff. Sticker on it from company property Rockwell International. Some interesting connectors on the back. It's a BNC, 5 coax D and a standard D on there. And on the front there's this. This looks like a fibre optic coupled image thing. It actually makes some quite funky rainbow patterns with the light. That white light is the light from the camcorder. Some interesting rainbow patterns, but it looks like a sort of fibre optic bundle. The way when you rotate it, the image sort of changes strangely enough. I've seen that before on other fibre coupled image intensifiers. On the side it says SIT detector head, UV scintillator option fitted. I'm guessing that's a different coating on the image intensifier to make it more sensitive to ultraviolet. Scintillators are also used for detecting radioactivity. They're sort of converting radioactivity to effectively flashes of light, but the fact it says UV, I suspect that may actually be more like a phosphor type thing. And also says gating polarity. One thing about image intensifiers, they're effectively an electro-optical device. You can actually control their optical properties electrically, and one application of this is to turn them on and off quickly, so it effectively acts the same as a mechanical shutter. The difference is that you can make them turn off really quickly, like down to nanoseconds. And when I was doing some reading up on this, I found that one application in military night view systems, to get around problems of mist, you can actually gate it so quickly that you can shine a light out onto a target, switch the light off, and then gate the image intensifier so it only detects the returned light, so that if you're sort of shining a light out at something through mist, the night vision scope doesn't see the light going out in the mist, it only sees the light reflected from the target, which is a pretty cool bit of high tech. Right, inside this bottom section, we've got a circuit board with a few components on here, and this is the first thing that told me this is not military stuff, because the board's not conformal coated, there's no seal or anything here. This is, you know, very obviously just room temperature, yeah, very well made, but yeah, room temperature, non-harsh environment type electronics. Because also you've got all these tantalum capacitors wiggling about everywhere. So I suspect there's a Vidicon tube in here. Vidicons are an image sensor, which was basically the standard image sensor used before CCDs and CMOS cameras came around. And one characteristic of those is that the video output comes off the front, and it's high frequency, but it's very high impedance as well. So you can't cable very far away from it, because the capacitance just kills the video bandwidth. So I think what we've got here is the front end. See, these transistors are actually in sockets, but although this is done on a PCB, this node here is actually wired directly from the transistor onto what I'm guessing are Teflon binding posts. So this is to keep the leakage and the capacitance as low as possible on this particular node. These other transistors are also in sockets. I think they're probably fairly early transistors. Those ones aren't. Maybe these ones are susceptible to getting blown up, because there'll be a high voltage from the image intensifier, so maybe if the image intensifier sparks over or something, these are the ones that tended to die, so they made them easy to replace by putting them in sockets. Let's see this little... Taking this back cover off, and this is what we like to see, high voltage. That's never a bad thing in my book. So this is going to be the high voltage supply for the image intensifier. There's a lead coming back here. Again, that seems to be that sort of rib there. I don't know whether that's because it's high voltage to increase the creepage distance, or maybe low leakage. This feels like PTFE Teflon coax, which is used for very high impedance circuitry to avoid leakage, and also dielectric, piezoelectric effects. There's a little board down here with a few odd bits and pieces on it. A few 5 transistors and a TO5 8-pin can there, maybe an op amp or something. And there's the back of the tube here, This is sort of nut there that clamps the tube into this assembly. I'm guessing this is a magnetic coil assembly, probably electromagnetic scanning for the Vidicon tube. On the front end, I've actually got this little switch here. This is actually accessible through this thing here, and there's a few various high voltage capacitors. This is the other end of that BNC, which looks like it goes through a 10 meg resistor, or sorry, in parallel with a 10 meg resistor, so that could be a number of things. I'm guessing it's the gate input to the image intensifier, because obviously that would need to be probably a high frequency signal, so my guess is that the voltage on there is a gate to turn the intensifier on and off. So there's some 10 kV rated cap there, 3 kV cap there, so I'm not sure these are either caps or MOVs. Can't see, they're covered in black gunk. And there's some high value resistors. There's what's this, 1000 meg ohms and 250 meg ohms, so that's obviously a voltage divider. And this switch looks like it's connected across to, yes, that switch connects this resistor in parallel, so that's probably just to control the voltage over on the image intensifier. It's probably a range select or something. One thing you'll notice, all these high voltage connections have got this black gunge on it. Now the reason for that is going to be to prevent corona. Wherever you've got an exposed high voltage connector, any slight sharp edges will produce corona losses, which produce ozone and all sorts of other nasties. So all this black stuff is just going to be anti-corona protection. Also you see on this input to the high voltage module, this has actually got some sort of rubber sleeving. This is all rubber, so it makes an airtight join to the output, again to avoid corona and flashover and sparking and other nasties. That's particularly important on something like this because it's got a Vidicon tube. It's got a very sensitive target, which would be very sensitive to interference, so any tiny amount of corona discharge on here will produce noise on the video output. I'll just pull this out as far as it will go before I have to disconnect these cables. And you can see this is the front end of the tube. There's the coax cable that's going from here down to this amplifier here, and there's a ground cable, and there's these other two cables, but it looks like I'm going to have to unsolder these cables to get this out any further because they don't unplug. So this is the tube assembly. The tube says it's a RCA custom tube, 4804H26, standard product 4804H, and I'm wondering how tightly integrated this image intensifier is to the tube. I was wondering if the electrons from the intensifier actually directly hit the tube target, so instead of converting light to light and then into an imaging tube, the fact it says silicon intensified target, I wonder if they're actually imaging that intensifier target directly in the tube. See if I can get this outer shell off and have a closer look and see if it's one whole piece or two separate pieces. And here's the tube without. This is just a machined plastic piece with some rings that clamp this thing in place, and this does look like this whole thing is sort of integrated onto the tube, actually bonded onto it as a single piece. And this is all ceramic. Yeah. Some little handwritten numbers and so on, and obviously this is very specialist, very low volume stuff, so these will all been probably hand assembled, hand tested, so there's various bits of handwriting on there. I'll just release some grub screws so we can get this coil assembly out. Now on the outside there's this is almost certainly something called mu metal, which is a metal alloy which has got a very high permeability, so it shields the influence of external magnetic fields. This was quite commonly used for things like CRTs in oscilloscopes, so this will be to prevent external magnetic fields distorting the scan of the Vidicon tube, and also maybe to a lesser extent avoid the magnetic field from the coils getting out. And there's quite a few windings here by the looks of it. There's quite a few. Right, there's a few layers of this mu metal shield, and inside the coil. So it looks like we've got one coil that's generating magnetic field in that direction. I'm not sure if that's focusing or acceleration. and I can just about see the ends of some other coils, which will be the deflection coils. This is the high voltage unit. It's helpfully marked ground and positive. I did fire it up, but unfortunately I think I went a bit over the top with the voltage and it now doesn't work. But it was producing sparks about 5-6 millimeters before it died, so I'm guessing that's probably something of the order of 10 kV. I'm guessing it's probably potted, but we'll have a go at unsoldering it anyway, just to see. It's actually been seam soldered all the way around for shielding. But I think we'll see if we can unsolder this. Right, when you're unsoldering big chunky bits of metal, this is where the Mac line comes in really handy, because you can just pump a shitload of heat into the joint. So we're just going to try and see if we can braid out some of this solder. It seems to be coming. Fortunately it's sucking back through that gap by capillary action into the braid, so this is Solderwick brand desolder braid, which is about the best stuff I've found over the years. It just works really well. Some people don't really like using braid, but that's generally because they haven't found good stuff. There is some really rubbish stuff out there, but for doing all sorts of desoldering, but particularly surface mount, it is very good stuff. Something like this that's got fairly thin, probably tin plate sides, you don't actually always have to get all the solder off. Sometimes you find that once you've got a gap there, you can actually crack it off because the solder's sticking to the plating, but also the solder's probably softer than the metal itself, so once you've actually started to get in there, you'll quite often just peel or crack off the rest of it. So we just need to unsolder enough to get a gap to get a blade in there. There we go, and pretty much what I expected to see. It's fully potted in this clear potting. It's so clear it's actually pretty quite hard to see the potting compound, but it's got this very clear, soft, probably silicone type potting compound. This will be a voltage multiplier. It'll probably be maybe two or a few stages of Cockcroft-Walton multiplier. Simple, what's this? One transistor oscillator, step up transformer, and then this will be a simple flyback type circuit, and then this will be boosting the voltage to its final output. Right folks, bit of a dilemma here. We've got this potentially quite interesting tube with this image intensifier integrated on it. Now I don't think there's any serious chance of actually getting it working because there's not really a lot of electronics in here, so this would undoubtedly have probably gone to a big box of gear that does all the Vidicon scanning and all the other stuff, and I have no real way of finding the pinouts of any of it. There's certainly not enough electronics on here for that to be all the scanning stuff. So, question. Do I keep this tube as it is, maybe flog it on eBay to a valve collector, or do I crack it open and look inside? I don't know, you tell me. Answers in the comments please. Crack it or sell it.